I guess most of you, at least once, saw a sheet of paper with curved edges and undulations. That was mostly done by an exchange of moisture between that paper and the surrounding air. And that is just one of the effects and the connections between the environment and an hygroscopic material like the paper. And today I'm going to briefly talk about air humidity in the printing industry. I'd like to go through these 5 points. So a brief insight into Carel industry and myself, introduction to printing processes, the most used one, why humidity matters, solutions for humidity control, and conclusions. So what about Carel? Carel is a company. It is one of the leading one, well-known worldwide, for control technology and humidification for air conditioning and refrigeration markets. So we are especially in HVAC and refrigeration markets. We operate globally. The headquarters are based northeast of Italy, close to Venice. There we have 9 production facilities around the world and many commercial subsidiaries to provide commercial support locally. We are also able to provide the same product quality all around the world because we use the same quality standards in all production facilities. We want to be close to the customers, and we spend time to learn our customers' business, to understand their needs. And there's also, there are many people that take care of specific application, like myself. They take care, more precisely, of industrial applications for HVAC market, like the printing industry, that I'm going to talk in short time. We continuously improve the performance. And one of the key strategies is the energy saving trend that is available in all our products. And of course, we offer integrated solution for vertical applications. So what about printing processes? Paper is mainly composed of cellulose. Cellulose is a highly hygroscopic material. What does hygroscopic means? Hygroscopic means that exchange moisture, absorbs and release moisture by the surrounding environment. And it's like the wood and other kind of hygroscopic material. And the exchange of moisture happens because paper and moisture tends to achieve an equilibrium between the moisture content of the material and the moisture content of the air. And this equilibrium changes based on the temperature and relative humidity of the environment. That's why these two thermodynamic properties highly affect the printing process and the paper itself. And this equilibrium affects the ink receptivity, the runnability, and the printability. These 3 main properties of the paper. The ink receptivity refers to the ability to accept and stabilize the ink on the surface. The runnability is more related on the workability of the paper in the production lines, and the printability is more related with the ability to reproduce the original image. All these 3 properties are highly affected by temperature and relative humidity of the environment. As a general rule, between 5 and 8% of moisture content of the paper is enough and suitable to achieve the best quality result. Pay attention that moisture content is completely different from relative humidity. So the moisture content is the amount of water compared to the weight of the paper. Relative humidity refers to the more on the environment and the amount of moisture content on a certain volume of air. Talking about printing methods, there are many. We can arrange them into 2 main groups: the traditional printing methods and the digital ones. The traditional printing ones requires a physical support that reproduces the original image, and it is used to reproduce the image on the paper itself. The digital printing, on the other hand, does not require any physical support, but it just uses digital interfaces to reproduce the original image on the paper. I just highlighted among all processes and methods the three most used ones. So the offset printing for the traditional methods, and laser printing and inkjet printing for the digital ones. And I'm just going to briefly introduce these methods. The offset printing is the most widely used around the world. About 50% of the overall of all printing around the world is done by the offset technology. For example, magazines and newspaper, so each kind of document that is reproduced in a number of copies is likely to be done with an offset printing. That's because the cost is low with the number of copies. Here below you see a simple scheme that represents the offset machine and on the production line. Starting from the left, you have the roll sheeter, the feeder, and the printing units. The printing unit is the core of the machine, and the offset printing works by adding one color after the other in order to achieve the full-scale color. Okay? So we need 4 banks of color: cyan, magenta, yellow, and black. And the mix of these colors, with the mix of this color, we are able to achieve each color we want. Then there's an oven, usually, a cooling unit, a blending unit, and the binding unit, and the output. The offset printing is highly effective, as you can imagine. There are 4 banks of color. The sheet of paper is going through all of them. So a variation in dimensions of the paper will affect the end result. And that is strictly related with the relative humidity of the environment, as we will see later. What about digital laser printing? This is just a simple picture that highlights the main components. So there's a laser, there's a mirror that's change the direction of the laser based on what the input data requires. There's a toner, and there's the huge cylinder in the middle, which is selenium coated one, so it is light sensitive. And the laser, the goal of the laser is to basically electrically charge this cylinder where it is necessary, and the charge part will absorb the toner, the toner particles, and then the cylinder will transfer this on the substrate. As you can imagine, low relative humidity of the environment might produce electrostatic discharges and then affecting the machine itself and the end result. We will see later more in detail some printing defects that might happen. Digital inkjet printing, on the other end, basically there's a head at the top that releases some ink droplets directly on the substrate, and based on the input data here, based on the input data, there's a deflector that basically help the droplets to go where they need to be. So why humidity matters? The paper runnability is strictly connected with the dimensional stability and the electrostatic discharges. So if you think about separation of relative humidity of the environment where the machines are working of only 10%, it means from 50% to 60, for example, it is likely to have a variation in terms of length between 0.1 and 0.2%. That seems low, it seems tiny amount. But if you think, for example, about offset printing, these are machines that work with huge sheets of paper. Each of these will end up with 8 A4 papers. And so a variation of 10% in relative humidity means a variation of 1-2 millimeters in width. And that is enough to have machine stoppages or to have some printing defects like the misregister we will see later on. As I said at the beginning, of course, huge variation, high relative humidity or low relative humidity produce loss of flatness of the paper, which is the most intuitive one. And the electrostatic discharges might affect both the machine itself, with, of course, high maintenance costs, and also printing defects. So what about printing defects? These are some examples of the most common ones, starting from misregister that mainly happen in offset printing. As I said before, this is caused by variation of the dimensions of the paper, or because too much strength from one blank color to the next one. And so you have the colors that are not well aligned one on top of the others. Then there's the blocking effect. The blistering, for example, happens when you have high relative humidity on the environment, and so high relative humidity of the air means high moisture content into the paper because of the equilibrium, okay? So that means, in this case, there's the paper that's full, it's completely covered by the color, then it goes through the drying phases, so water tends to pass from the paper to the air, but it is not able to do that. So you have the blistering so-called effect. So it's sort of bubble behind the color. The ink mist is mostly common in inkjet printing. If you remember the image that I showed before, that's more or less the same, but the droplet, instead of going straight down onto the paper, is deviated because of electrostatic discharge. Dot gain is explained by the image itself. So with high relative humidity, you are not able to have a nice image quality as expected. The other one is a doubling that happens in offset printing when the humidity of the air is too low, and the cover breakage when relative humidity is too low too. This is just a summary of these printing defects for each of the most used technology that I briefly introduced before. So what about humidity control? A humidification system is made up of three main parts: a feed water treatment system, which is not always mandatory, an humidifier, and a distribution system. Of course, our goal is to keep the relative humidity of the environment as much constant as possible, so that the moisture content of the paper will be constant, and so we will not end up with the defects I showed before. The humidification system can be installed in duct humidification or in direct room humidification. Duct humidification, of course, is the easier way to do that because we have a confined space that we can easily manage, whereas in direct humidification it is more complex because there are hardly predictable effects, like, for example, natural air flows, gates, doors that opens, operators inside. And with direct humidification, you can easily imagine we have a sort of moisture cloud directly put into the environment, so it requires a certain free space to let the moisture evaporate in the surrounding environment. Both of these two applications, let me say, can be managed through an isothermal system or an adiabatic one. What's the difference? So the isothermal humidifiers, the goal of this unit is to produce steam. And steam is easily absorbed by the air. Steam can be produced by using electricity or natural gas. On the other end, the adiabatic humidifiers has the goal to produce tiny droplets that will naturally evaporate in the air by absorbing heat by the surrounding air. That's why here, this is the psychrometric chart. If you think about a winter case, starting from the point A, which is at -4 degrees, what could be 70% relative humidity, and we want to achieve the point D, which is our set point inside, which is 18 degrees and 50%, we have two options. At first, we have to preheat the air, so from A to B. Then we can use an isothermal humidifier from B to D. And as you can see, the dry bulb temperature, which is on the x-axis, doesn't change too much. Whereas on the other end, if we decide to use an adiabatic humidifier, so by spraying tiny droplets into the environment, then we need to preheat more up to point C, and then use an adiabatic humidifier. That's because each droplet, to completely evaporate, will absorb heat. So with adiabatic humidification, we both have an increase of humidity and also decrease in temperature, so an evaporative cooling effect.
1 minute, please.
Yes. So, do we have, what's the best one? Isothermal or adiabatic? So, it depends. This is the answer. It depends on the scenario. It is always a trade-off between hydrogen, capacity, power consumption, free space, and type of water used. Conclusions. Temperature and relative humidity must be controlled to ensure an efficient process in the printing industry. Changes in relative humidity can cause dimensional variation and other defects, as I briefly highlighted before. Humidity system should be used in printing facility to increase the overall production efficiency and ensure the best quality results. The average set point is between 55–60% for offset printing and 50–55% for the digital printing. Adiabatic humidification has the double advantage to both humidify and cool down the environment. So the production facilities usually has natural heat flow coming from the machine itself. So an adiabatic humidification might contrast the heating provided by the machine itself. Of course, it is highly suggested to have a professional support from the beginning from us or other companies that supply humidifiers in order to have the best support and understand which is the best trade-off for the specific case. Thank you.
Thank you very much.